Ever wondered how computers interpret and process the vast amount of data they encounter? Today, we're diving deep into the world of data representation in computer architecture. At its core, all data in a computer is represented using binary digits or bits. These bits, which can either be 0 or 1, form the foundation of data representation. But how does a computer translate these binary digits into something meaningful? Let's explore. When it comes to representing numbers, computer architecture employs a few strategies. Integers, for instance, are represented using binary numbers. There are a few common formats for this, including signed magnitude, 1's complement, and 2's complement representations. Floating point numbers, on the other hand, require a different approach. These are represented using a combination of a sign bit, an exponent, and a mantissa, the part that represents the significant digits of a number. This allows the representation of real numbers with fractional parts. Next, we have character representation. Here, character encoding schemes come into play, with ASCII and Unicode being the most common. Each character is assigned a unique binary code, enabling computers to store and process textual data. And what about instructions? These are represented using machine language, consisting of binary patterns that the central processing unit or CPU can understand and execute. These instructions can include operation codes, operands, and various addressing modes. Data structures also have their own representation. Arrays, for example, are represented by allocating contiguous blocks of memory with elements accessed using indices or pointers. Structures and records group together multiple data elements of different types into a single composite data structure. Pointers, meanwhile, are represented as memory addresses, allowing indirect access to data stored elsewhere in memory. The representation of image and audio data involves specific formats like bitmap for images or waveform audio. Multimedia data can also be represented using compressed formats like JPEG or MP3. Data transmitted over networks often follows protocols like TCP/IP, which define standardized formats for headers, packets, and payloads. Even metadata has its representation. This might include file attributes, timestamps, and data structure definitions, all represented using specific formats or standards. Files and file systems use structures and metadata to organize and store data on storage devices, such as hard drives or solid-state drives. Databases, meanwhile, represent structured data using tables, rows, and columns, with various data types and constraints defined for each field. In conclusion, understanding how data is represented is crucial to both computer architecture and programming. It informs how data is manipulated, stored, transmitted, and interpreted by computer systems. Different data representations offer different trade-offs in terms of efficiency, precision, complexity, and compatibility with hardware and software systems. Understanding these nuances can empower you to make more informed decisions in your programming and data management endeavors.